Hi folks, howdy. We're just going to do a little bit of work here on Earth-Sun relations, okay? This will be the last videos I'll send for this year. Next week we'll do something a little bit different, so just keep an eye out for the forecasts, which will be sent out to you on Monday. Alright, so again, head up with all your stuff here, date and objective, and we'll start. So again, we start off with this picture, alright, the blue marble taken in 1972. So we're approaching 50 odd years ago now. Alright, this was the first full picture taken of the full Earth. Okay, before that we had pictures of half the Earth, but this was the first one to show it as a full sphere. Alright, so what we know is the Earth travels around the Sun, and as it does that, it's also spinning on an axis which goes through the planet. So we have a combination of things here. We used words like revolution and rotation. Okay, so the Earth rotates on its axis as it revolves around the Sun. Both of those things bring different impacts, as we'll see in a little bit. So first of all, some little extra notes you can make. Okay, we made some of these notes before, but we've latitudes and longitudes, which are the lines that go up and down the Earth and across the Earth. Okay, first of all, we got our longitudes. These are the ones that run north to south. So you got that note here. So they run north to south, but they measure how far west or how far east a place is. Okay, the main line of longitude is our prime meridian, and it'll always be at 0 degrees. We'll look at those degrees in a little bit when you do a little task. All right, so the lines of longitude run north to south, North Pole to South Pole. They all cross each other at the poles, but they tell us how far east or west you are in the world. Okay, so for example here we can see the prime meridian runs through England, and then the Bahamas is 30, 60. It's not a full 90, we're about here, so it's about 75 degrees west is where we are. Okay, west of what? The prime meridian. Every 1 degree of longitude equals a time difference of 4 minutes. Alright, so 360 degrees of longitude, okay, there's 360 degrees of longitude, 180 in each hemisphere, equals our 24 hours. Alright, so we'll move on. Our other bits are lines of latitude then. These are the opposite. We have the equator. Let me see, sorry, there should be some more information before that. Okay, lines of latitude are the ones that run parallel to each other. They run east to west, but they tell us how far north or how far south we are of what? Of the equator. So the equator runs through the middle of the planet, dividing into north and south hemisphere. Then our lines of latitude tell us how far north or how far south we are. Two other important lines of latitude are Tropic of Cancer and Tropic of Capricorn. Okay, and again, these are all measured north and south in degrees. So another little note to add about latitudes and longitudes, and this is a good little diagram to help you understand. We've got the red line is our prime meridian. Here's England. Okay, so it comes straight down here, and then around the middle is our equator going east to west. Alright, longitudes measure how far east to west location is. Alright, how far location a person is from the prime meridian, shown in red. Okay, all longitude meets at the north and south pole. Latitudes, these run, alright, these run east to west, but show how far north or south a person is from the equator. Alright, and they run parallel. Lines of latitude never cross. Okay, so that's what we have there. Right, another little subheading with some more notes to add. Again, this is just a recap going back over our Earth-Sun relations. Okay, the circle of illumination is very simply the division between day and night over the Earth. Okay, the circle of illumination always bisects the equator. It doesn't always bisect all the lines of latitude, but it will always bisect the equator. So again, think about what the word illuminate means. What does it mean to illuminate something? It means light it up. So the circle of illumination is just simply the division between night and day. That's all it is. Then we had our solstice versus our equinox. So we need to do a little bit of work about this. So the equinox, first of all. Alright, this is when the circle of illumination bisects all latitudes on the spring or autumnal equinox. So you can see here, it's when the Earth is facing the Sun at a right angle, and all of the lines of latitude, okay, which run this way, parallel to the equator, all of them are bisected by the circle of illumination. Alright, at this time, all places will have equal length of days and nights. at these times. So in spring and fall is when we have our 2 equinoxes. Very simple, then just the opposite is true for our solstice. All right, the circular illumination does not bisect all the latitudes in the summer and winter in our other 2 seasons. So now you can see the lines of latitude are at an angle here, okay, and not all of them. It's usually our Arctic Circle and Antarctic Circle. They're the ones which aren't bisected, because the Earth was like this and now it's tilted one way or the other. The winter solstice is the day a place gets the least sunlight for the year. The summer solstice, that same place experiences the longest amount. So in the summer, all right, we'll have our summer solstice when we experience the longest amount of daylight hours we can. And then the winter, it's the opposite, right? So again, a couple of little things here. We've gone through some of this, so you can go back and look in your notes, okay? Sort these boxes into impacts of the Earth's rotation or revolution. So we got 1, 2, 3, 4, 5, 6, 7, 8. 8 different boxes here, okay? So I will pause the screen, you can have a read through them and then sort them in your notes under the headings, okay? Try not to look back, try and do it yourself, but if you need to look back to your old notes, you can. So pause there now and have a go. Okay, so here they are sorted. There's more impacts at the rotation than there is about the revolution. All right. So again, but the revolution has 2 big ones: the changing the seasons, which also changes our weather, and the changing lengths of days and nights. Okay. The rotation makes us experience day and night because we rotate on our axes, but the changing lengths of our days and nights is about how we revolve around the sun. Okay. Also, the rotation is about how the sun always appears in the east and sets in the west. Again, that's because of the direction we're spinning. Okay. So make sure you got all those right, give yourself a tick, and we move on. The next little task I want you to do, if you remember this diagram, again, I want you to try and do as much of it as you can from memory, okay? But we did this diagram back in your notes as well. Now, I don't know if I have a corrected version, I don't. So I want you to draw Earth here, okay, and then we got the 4 little, sorry, sun, my bad, sun here, and the 4 little Earths moving around it, okay? So you will see at these 2 points here, the equator, all right, is at a right angle to the sun. So what 2 things will occur there? Whereas here, okay, the Earth is tilted away, or to, sorry, the Earth is on a tilt. All right, so you're going to have a different thing happening there. What you can do as well, the first thing, add northern hemisphere, northern hemisphere, northern hemisphere, northern hemisphere. Okay, that should make it easier as well as a start. So when the Earth is like this, the northern hemisphere is tilted away, it's facing away from the sun. So again, you can add some little notes like we did before. What season do you think that will be if we're not facing the sun? What about the lengths of the day? Will we have longer or shorter days? All right. Whatever this one is the opposite. In this case, the northern hemisphere is pointed towards the sun. So will we get more or less sunlight? Will we have longer or shorter days? What season do you think it is? All right. And again, I want you to add equinox to 2 of these and solstice to 2 of these as well. So have a go, try and do as much of that as you can, and then go back to your old notes in the Earth-Sun relations bit. Okay? Now, also, then I want to look back at this. You were all given this map as well quite a while ago. I'm going to start a second quick video, and I'll go through this, and we look at a little bit of calculating time using longitude. All right? So we can pause there. I'll be back in a minute.